In this video, I'm just going to go over a few examples of using implicit differentiation. So let's look at the first example. Okay, so we're going to start from left to right. So I'm going to take the derivative of a constant. Derivative of a constant is always 0. So this requires no product rule, no chain rule, just the derivative of 3x is 3 plus. Now this one requires product rule. So this is my first term, and the blue is going to be my second. Okay, so I'm going to take the derivative of the first, which is 4x, times the second, doesn't change, plus the first times the derivative of the second. So we're going to have 2y times y prime. So remember, the entire goal is to solve for y prime, so I'm going to move both of these terms to the other side of the equation. So I have minus 3 minus 4xy squared. So I'm going to have minus 3 minus 4xy squared is equal to 2x squared times 2y y prime. Now I can clean the right-hand side of this equation up a little bit, so I'm going to have minus 3 minus 4xy squared is equal to 4x squared y times y prime. So I need to, y prime. So I need to get rid of this 4x squared y. So I'm going to divide both sides by 4x squared y, which is going to give me that y prime is equal to negative 3 minus 4x y squared over 4x squared y. And that's my final answer. Second problem, very similar. So this requires no chain rule, nothing fancy. We're going to drop our exponent. So I'm going to have 15x. Always remember to subtract that 1. So that's going to be squared plus. Now this does require product rule. So again, I'm going to say first term and second term. So plus comes just from the equation. So the derivative of the first is 1 times y squared, the second term, plus the first times the derivative of the second. So chain rule says we bring the 2 down, subtract 1, times the derivative of the inside, which is y prime, is equal to, again, we have that product rule. So first term, second term. So I have the derivative of the first is 15x squared times the second plus the first term times the derivative of the second. So I have 3y squared times y prime. Okay, so I'm going to do a little bit of cleanup before I even worry about moving sides. So I'm going to have 15x squared plus y squared plus 2xy y prime is equal to 15x squared y cubed plus 15x cubed y squared times y prime. Now right here is where it's going to make the difference in your answer. So your answer could have completely opposite signs. So as long as every sign has been flipped, you're fine. I'm going to choose to move this onto this side. So I have 15x squared y squared is equal to 15x squared y cubed plus 15x cubed y squared times y prime minus 2xy times y prime. Okay, then I'm going to move my 15x squared y cubed, and they're so similar, don't get tripped up and combine wrong things. So 15x squared y squared minus 15x squared y cubed, and I'm going to go ahead and factor out my GCF of y prime. So I have 15x cubed y squared minus 2xy, and I'm going to divide that on both sides. So I have y prime is equal to 15x squared y squared minus 15x squared y cubed all over 15x cubed y squared minus 2xy. And you have a factor of y and a factor of x that you can take out of everything. So that's going to drop me by a degree. So I have 15x squared y minus 2. And that's going to be my final answer. So this one has some implicit and some chain rule. So this first term doesn't require anything, just regular derivative. So I'm going to drop my 3 and give me 6x squared. Make sure you're subtracting. So this is chain rule, so I'm going to drop my 2 times 3xy plus 1 times the derivative of the inside, and this requires product rule. So I have the first, derivative of the first is 3 times the second, plus the first times the derivative of the second, and then the derivative of 1 is just 0. Okay, so I'm going to have to do a lot of distribution because I've got to be able to isolate that y prime term. So I have 6x squared. I'm going to go ahead and distribute this 2 first, which will give me 6xy plus 2 times 3y plus 3xy prime. Okay, so you're going to multiply binomials like you always have, distributive property. So I'm going to have 18xy squared plus 18x squared y prime. 2 times 3y is 6y, and 2 times 3x y prime is plus 6x y prime. So I'm going to move both of these terms to the other side so that I can have my y prime terms on a side by themselves. So that's going to give me 6x squared minus 18xy squared minus 6y is equal to, and I'm going to go ahead and factor my GCF out, y prime times 18x squared y plus 6x. So I'm going to divide that away to isolate my y prime term. So that's going to give me y prime is equal to 6x squared minus 18xy squared minus 6y all over 18x squared y plus 6x. So many x's and y's definitely want to simplify, but they don't. Notice this term has no y, this term has no x, no y. But what we can do is factor out a factor of 6. So I'm going to have y prime is equal to x squared minus 3xy squared minus y all over 3x squared y plus x. It's going to be my final answer. So this one has a little bit of trig in it. So we want to remember, normally you see parentheses there to let you know that that's the argument. So we have some chain rule on top of implicit. So this is chain rule on top of having to use implicit once we take the derivative of the inside. So the derivative of sign, regardless of what's on the inside, is cosine of the argument times the derivative of the argument, which we're going to have to use product and implicit within that. So the derivative of the first is 4x times the second plus the first times the derivative of the second, which is 3y squared times y prime, is equal to, this is regular derivative, so I'm going to have 9x squared, and the derivative of a constant is 0. Okay, so again, a lot of nastiness. Okay, I would probably go ahead and divide by this cosine versus distributing it to every term. So I'm going to divide by cosine of 2x squared y cubed on both sides. So I have 4x y cubed plus 2x squared times 3y squared y prime equals 9x squared over cosine of 2x squared y cubed. I'm going to go ahead and clean this term up here as I move this one to the other side. So minus 4xy cubed. So I'm going to have here 3 times 2 is 6x squared y squared times y prime is equal to 9x squared over cosine of 2x squared y cubed minus 4xy cubed. So I'm going to divide out that 6x squared y squared. So I have y prime is equal to 9x squared over cosine of 2x squared y cubed minus 4xy cubed all over 6x squared y squared. Now if you want to get rid of that fraction within a fraction, this is not an unacceptable answer, but if you don't like the fraction within a fraction, you can multiply top and bottom of this equation by that cosine, which is what you would have done here by distributing. It's the same answer. It just depends on what you and or your professor or instructor prefers. But just to show you, in case this happens to pop up as a multiple choice question, we have y prime is equal to 9x squared minus 4xy cubed cosine of 2x squared y cubed all over 6x squared y squared times cosine of 2x squared y cubed. So either is an acceptable answer. It's just a matter of how you worked it. You could have distributed here and came to the same conclusion. Okay, so the last one that we're going to do does contain a natural log. So we have to remember how to do those. So let's look at the first term. Nothing fancy, just a regular derivative. I'm going to drop my 2, so I have 6x and 2 minus 1 is 1. Derivative of a constant is 0 is equal to, so remember that the natural log, the derivative is 1 over the argument times the derivative of the argument. So I have 1 over 5xy squared times the derivative, which is going to require product rule. So I have the derivative of the first, which is 5, times the second, y squared, plus the first, 5x, times the derivative of the second, which is 2y, y prime. Okay? So I would probably multiply both sides first by this 5xy squared to get it out of the bottom and away from what I need to isolate my y prime. So that's going to give me 30x squared y squared is equal to 5y squared plus, just a little cleanup here, 10xy y prime. So I'm going to subtract 5y squared on both sides. So I have 30x squared y squared minus 5y squared is equal to 10xy times y prime. So I'm going to get that away from my y prime. So I have y prime is equal to 30x squared y squared minus 5y squared over 10xy. So I have just a little bit of algebra. I can divide out of 5 and a factor of y. So it's going to give me 6x squared y minus y. So this divided by 5 and y divided by 2x. And that is going to be my final answer.